The first problem is a hydrogen atom is placed in a magnetic field of 3 Tesla. Calculate the energy difference between ml is equal to minus 1 and ml is equal to plus 1 components in the 2p state. The present problem deals with the Paschen-Beck effect in hydrogen atom. If the field strength is low, hydrogen atom will show anomalous Zeeman pattern. But if we increase the field strength, then the anomalous Zeeman pattern approximate to normal Zeeman triplet. Therefore, in this problem, we have to use the equation for normal Zeeman effect. Consider the level 2p. For 2p, L is equal to 1. Let E0 be the energy of that particular state when the magnetic field is 0. When you switch on the magnetic field to 3 Tesla, the energy level 2p will split up into 3 components. This is because the energy of the state due to the interaction is E is equal to E0 plus mu b B0 ml. Now for L is equal to 1, ml can have 3 values. Therefore, energy also can have 3 values. The value of the energies are E0 plus mu b B0, E0, and E0 minus mu b B0. This is because the level L is equal to 1 will split up into 3 components corresponding to ml is equal to plus 1, 0 and minus 1. Now in this problem, we have to find out the energy difference between ml is equal to minus 1 and ml is equal to plus 1. The energy difference between ml is equal to minus 1 and ml is equal to plus 1 components of 2p state. The energy difference between ml is equal to plus 1 and ml is equal to minus 1 is delta E. Delta E is equal to the initial energy minus final energy, that is E0 plus mu b B0 minus E0 minus mu b B0, and that is equal to 2 mu b B0. That is equal to 2 mu b B0. What is mu b? Mu b is the Bohr magneton, that is equal to 9.27 into 10 raised to minus 24 joule per Tesla. Mu b is called the Bohr magneton. You have to remember the value of the Bohr magneton. Mu b is equal to 9.27 into 10 raised to minus 24 joule per Tesla. It is given that B0 is 3 Tesla, therefore the energy difference delta E is equal to 2 times 9.27 into 10 raised to minus 24 into 3, that is equal to 5.562 into 10 raised to minus 23 joule. This is the answer in joule. Let us convert this joule to electron volt, and we know that 1 electron volt, that is equal to 1.6 into 10 raised to minus 19 joule. Now we can write the energy difference in terms of electron volt. Now delta E is equal to 5.562 into 10 raised to minus 23 divided by 1.6 into 10 raised to minus 19. Now the answer will be in electron volt, and this is equal to 3.476 into 10 raised to minus 4 electron volt. That is the energy difference between ml is equal to plus 1 and ml is equal to minus 1 component of the 2p state is 3.476 into 10 raised to minus 4 electron volt. The next problem is find the values of L and S of the ground state of nitrogen. The electronic configuration of nitrogen is 1s2, 2s2, 2p3 with 2p valence electron. For 2p electrons, L is equal to 1. Therefore, the value of ml are minus 1, 0 and plus 1. The electrons are arranged in such a way that the value of ms is 1 by 2, 1 by 2 and 1 by 2, which is consistent with the Pauli's exclusion principle. Now, what is ml for nitrogen, which is sum over ml? Ms for nitrogen is sum over Ms, and this Ml for nitrogen can take the value from minus L to L, and Ms can take the value from minus S to S, and capital J can take the value modulus of L plus S to modulus of L minus S. Now what is capital ML, which is sum over small ml, and here small ml, that is minus 1, 0 and plus 1. Therefore, we can say that capital ML is equal to 0, which is the maximum possible value of capital ML, which is equal to 0, means we can clearly say that the value of capital L is also 0, because ML can take the value from minus L to plus L. Now capital MS is sum over MS, and we can say it is 1 by 2 plus 1 by 2 plus 1 by 2, that is 3 by 2. Now this is the maximum possible value of MS. Now since MS can take the value from minus S to S, it is evident that the value of S is 3 by 2. Now capital J can take the values from modulus of L plus S to modulus of L minus S. Modulus of L plus S to modulus of L minus S, that is modulus of 0 plus 3 by 2 to modulus of 0 minus 3 by 2, that is capital J can have only one value, that is 3 by 2. Capital J can have only one value, that is 3 by 2. Now how do you write the term symbol? It is 2s plus 1 L J, where 2s plus 1 is the multiplicity. In the present problem, L is equal to 0. When L is equal to 0, it corresponding to S state. Therefore, the term symbol is 2 into 0 plus 1, 2 into 3 by 2 plus 1. The term symbol is 2 into 3 by 2 plus 1, because capital S is 3 by 2. Then L is equal to 0 corresponding to S state. Then J is 3 by 2. Therefore, the term symbol is 4S 3 by 2. Or we can say the ground state of nitrogen is 4S 3 by 2. The next problem is calculate the vibrational energy levels of an HCl molecule assuming the force constant to be 516 Newton per meter. In the present problem, let us use the simple harmonic oscillator model. Suppose the HCl molecule vibrates simple harmonically, then the equation for vibrational energy levels is E nu is equal to nu plus half H omega oscillation in joule, where nu is the vibrational quantum number. Omega oscillation is the oscillation frequency, which is equal to 1 by 2 pi root of k by mu hertz. Take the mass of hydrogen as 1.008 AMU and mass of chlorine as 35.453 AMU. Then the reduced mass of HCl molecule is mass of hydrogen into mass of chlorine divided by mass of hydrogen plus mass of chlorine into 1.66 into 10 raised to minus 27 kilogram, and that is equal to 1.008 into 35.453 divided by 1.008 plus 35.453 into 1.66 into 10 raised to minus 27 kilogram. That is, the reduced mass mu is equal to 1.627 into 10 raised to minus 27 kilogram. This is the reduced mass of HCl molecule. Now let us find out the oscillation frequency omega oscillation, that is equal to 1 by 2 pi root of k by mu, where k is the force constant, which is given in the question as 516 Newton meter, and the reduced mass is 1.627 into 10 raised to minus 27. Therefore, omega oscillation is equal to 1 by 2 pi. Then 516 divided by 1.627 into 10 raised to minus 27. That is omega oscillation. That is the oscillation frequency is 8.963 into 10 raised to 13 Hertz. Now let us find out H omega oscillation. H omega oscillation, that is equal to 6.626 into 10 raised to minus 34 into 8.963 into 10 raised to 13 Hertz, and that is equal to 5.939 into 10 raised to minus 20 joule. This is the value of H omega oscillation. Now let us convert joule to electron volt. We know that 1 electron volt is 1.6 into 10 raised to minus 19 joule. Therefore, H omega oscillation is 5.939 into 10 raised to minus 20 divided by 1.6 into 10 raised to minus 19. Now the answer will be in electron volt, and that is equal to 0.371 electron volt. Now let us write the expression for vibrational energy level. E nu, that is equal to nu plus half H omega oscillation, that is equal to nu plus half into 0. Nu plus half H omega oscillation is equal to nu plus half into 0.371 electron volt. This is the expression for the vibrational energy levels of HCl molecule, assuming that the oscillation is simple harmonic. The next question is, HCl molecule has a rotational constant B value of 1059.3 meter inverse and a centrifugal distortion constant D of 5.3 into 10 raised to minus 2 meter inverse. Estimate the vibrational frequency. In the present problem, the rotational constant and the centrifugal distortion constant of HCl molecule is given. We have to determine the vibrational frequency. The centrifugal distortion constant D is given by 4b cube by omega square. In the present problem, the rotational constant B is given as 1059.3 meter inverse and the centrifugal distortion constant D as 5.3 into 10 raised to minus 2 meter inverse. We have to determine the vibrational frequency. We have W is equal to square root of 4b cube divided by D. Now let us substitute the value of B and D. W is equal to square root of 4 into 1059.3 cube divided by D is 5.3 into 10 raised to minus 2, and that is equal to 299,516.33 meter inverse. Therefore, omega is equal to 2.995 into 10 raised to 5 meter inverse. Here the vibrational frequency is in wave number unit. The next question is, the spacing between the vibrational levels of carbon monoxide molecule is 8.45 into 10 raised to minus 2 electron volt of energy. Calculate the frequency of the molecule. In the present problem, the spacing between the vibrational energy levels of CO molecule is given. From that data, we have to determine the frequency of the molecule. We know that if delta E is the spacing between the vibrational levels, then this delta E is equal to H omega oscillation, where omega oscillation is the oscillation frequency of the molecule, and we can write it as delta E divided by H. In the present problem, the spacing between the vibrational level is given as 8.45 into 10 raised to minus 2 electron volt, and we have to convert it into joule by multiplying with 1.6 into 10 raised to minus 19. Then divide it by H, that is equal to 6.626 into 10 raised to minus 34. Therefore, the answer is 2.04 into 10 raised to 13 Hertz. The next question is, an unpaired electron gives ESR resonance at 35 gigahertz when the magnetic field is 1.3 Tesla. Calculate electron G factor. In the present problem, we have to determine the electron G factor. We know that the resonance condition for ESR is H nu is equal to G mu B B0, where G is the electron G factor and mu B is the Bohr magneton given by 9.27 into 10 raised to minus 4 joule per Tesla. From this equation, we can determine the electron G factor. In the present problem, B0 is given as 1.3 Tesla and the frequency is 35 gigahertz, that is 35 into 10 raised to 9 hertz. Now, from the ESR resonance condition, we can say that the electron G factor G is H nu divided by mu B, B0, where mu B is the Bohr magneton. Therefore, G is 6.626 into 10 raised to minus 34 into 35 into 10 raised to 9 divided by 9.27 into 10 raised to minus 24 into 1.30. That is, the electron G factor is 1.90.